Welcome. We're so glad that you could join us today for Get Smart, Making Machines Work for You, the first installment of our Smart Manufacturing series. I'd like to do some quick introductions before we get this show on the road. First, I'd like to show you the webinar console. You'll see some engagement tool icons centered at the bottom of your screen, and I'll go over them quickly from left to right. All of these are completely customizable. You can change the sizes and location of each box and add or remove them from your screen by simply clicking on each icon. Click around. Get wild. First, we have the help icon. If you're running into any technical issues, head here ASAP. An IT pro tip. When in doubt, refresh your browser. It usually solves most problems. Next, there's the media player. This controls the box that I'm currently speaking from. If you're new to the platform, please be aware that if you maximize this screen, you won't be able to see the accompanying slides. Then we have the slideshow icon. That you got it, controls the slides. We'll be advancing these for you as the presentation progresses, so you can sit back and relax. One note, today David will be showing you some detailed example photos, so remember that you can expand this box to get a better view. Then we have the resources list. Here you will find any accompanying files, links, and literature. Included here is a copy of today's slides. This is packed for this webinar, so be sure to check it out. One of the most powerful icons for you is the Q&A. Feel free to submit a question at any time. We will have a few minutes at the end for David to cover questions, and if he doesn't get to them, we'll make sure that you get a response after the webinar. Next, we have the speaker bio. This gives you some background information about David, John, and Jeremy and how they came to be webinar hosts extraordinaire. One of the most valuable tools for us is the survey tool. If you could complete the survey at the end of the webinar, we'd really appreciate it. It's available at any time, but will appear on your screen at the end of the webinar. We will use this feedback to make sure that we're providing you the best experience possible in future webinars, and it will aid us in making sure that we deliver content that you want to hear. The little envelope is a contact us tool. If you're interested in learning more about this topic or any others from one of our specialists, please reach out and someone will be in contact. Next, we have the calendar icon, which allows you to book a meeting with one of our hosts. This is a chance to chat one-on-one with someone from our team via video or phone about smart manufacturing. Finally, we have the registration icon, where you can register for the next webinar in the Get Smart series and watch any of our past webinars on cybersecurity or hygienic design. You're about to get hit with a lot of knowledge, but don't worry if you miss something. A recording of this webinar will be available on demand, and we will send you a link once it's published. Now for the most important introduction. Today you'll have the pleasure of listening to David Rauch from Rockwell Automation, who is one of the first in his industry to see the value in building a smart machine and implementing it to great success. David doesn't just talk the talk, although we're really glad that he does, but he's actually walked the walk in the field. You'll also be hearing from Jeremy Watkins and John Simon, who are the go-to guys at CBT where sensors and safety are concerned. They take the concept knowledge that David will be providing and help you put it into action with specification and application expertise. So without further ado, here's David.
Well, thank you very much, Callie, for that introduction, and welcome to the Get Smart webinar series. As she said, my name is David Rauch. I've been with Rockwell only about a year, but for the past 3 decades, I've been working in equipment development and R&D as far as for different OEMs. And for the last 16 years or 15 years of that, I've been responsible for intelligent controls for our equipment. And during that time, I kind of gained some experience of some things that worked and didn't work. And so when we go through this Get Smart series, I'd like to use some of this background as examples to help you to kind of understand the concepts of what we did. The reason being is kind of my feeling is if I talk from my experience, I think it can be more relevant. And when you hear something that might trigger, hey, that's something we could use, then you can book a meeting with either Jeremy or John, and they can get hold of me, and maybe we can talk through of how this can be applied to your equipment and help you to differentiate your equipment, okay? The first thing I'd like to do, though, is I'd like to lay a little bit of groundwork for the smart machine. It was, I think, about maybe 6 months ago, I was reading on IoT, the number of devices that are on the internet, right? And they were expecting about 50 billion devices to be on the internet by the year 2020. Well, whether it's because of the pandemic or what caused it, it didn't quite reach there. And, it's about every 5 years, it doubles the number of devices that get put on the internet. But if you think about it, if you know the law of doubling, that can't go on indefinitely. But so by, 2025, we're probably going to get close to that number or maybe a little bit over, because we're right in the 30 billion close to number of devices that's on the internet. But it's growing rapidly. And, it's the consumer market that really is driving this at this time. But I'm telling you, there is a lot of advantages for the OEM industry to kind of start jumping on this bandwagon. That's really where you take all this information that you can gather from sensors on your equipment and merge the physical worlds with the virtual worlds. I like to play a game with my grandson, and it's kind of an augmented reality type of a game. And we take our smart device, phone or tablet, and we walk around, and with the camera turned on, we're looking around, and you can find things that's in the virtual world, but it's overlaid on into the real world. And it's just, it's that interaction of the mind with the device and, the GPS and, the multi-axis accelerometers in your phone, that you can use this to make a really interesting game. But you start merging these physical worlds and these virtual worlds together, and it adds a lot of depth, to what you're doing in a game. It's more than just a board game, right? There's a lot of interaction and a lot of visualization. But you take all this information that you're gathering, and you can develop safe and collaboration, with robots and equipment. And you can kind of use this to differentiate your equipment. And from this, you can develop what we call predictive or prescriptive maintenance. And this is something that I want to get into a little bit. But the predictive and prescriptive maintenance, I'm telling you, that is huge. And if you have a customer that goes through downtime issues because of your equipment, and you can tell them, hey, we can detect these ahead of time, or we can head these off at the pass, so to speak, you can really differentiate your equipment. And, kind of maybe the ultimate of this is using wearables. Wearables or remote devices, right? When you have this wearable or this virtual device that you can use, or you can develop some augmented reality, this is where you're getting the visualization of your equipment, that may be things that you can't see readily. But you always think, you hear the adage, picture's worth 1,000 words. Isn't that right? If you look at that game my grandson and I play together, if you tried to read a script or read what to do, it just takes so much time processing that information. But if you can see it on a mobile device and react to it, that's big. I remember one of the first things I did, and this, I think it was back like in '94, and VBA code was on Microsoft Word, and we had a PC connected to a PLC, and I was working on taking a PLC when something would happen, we'd know, okay, this is an alarm, and we'd take that, and I wrote some VB code in Word, and it would trigger the manual, and it'd bring the manual up, and it'd jump to a page of the manual and tell the operator, hey, go look at this page. Because one of my frustrations was everybody was always losing the manual, or if they had the manual, trying to flip and find out what they needed to get to. And that was kind of the first step. We have gone so far beyond that it can really be a great benefit to you. And so, but I want to ask you a question. Is your home smarter than your equipment? I'll tell you another story. It's about a friend of mine. We were talking the other day, and he bought a home in Hawaii, right? And as we were talking about his home in Hawaii, we got on the subject about, are you ever concerned about what's going on in your home, half a world away, and you don't know what's going on? He says, you know what, David? He says, I know about as much as what's going on in my home in Hawaii than I know here. I got a Ring doorbell that whenever somebody walks up to my door, I can see what they're doing. I've got a thermometer. And in that thermometer, I can tell, is the thermostat set to a good setting? if I have somebody that needs to go do some work on, our apartment or our house over there, I can let them in from here. I can actually unlock the doors so they can get in. I started thinking about that. I said, that's where the consumers are driving this market. There's so many things you can do, whether it be with thermostats you can change or, these outlets I'm looking at buying for my house where you can turn lights on or off if you're on vacation, or the Ring doorbell or videos that you can see from wherever you are. The other day, my daughter came home and she told me, she says, "Hey, Gabriel's bedroom smells hot." And so I go, let's go take a look. And so we walk over into the bedroom and, we're walking around. I'm starting to think, I said, my smoke detectors are really old and out of date. I really need to look at updating these. So I got some new smoke detectors, and these things, they're just amazing. So I'm putting one in every bedroom, got one up in the attic, I got one down in the basement, and so it doesn't matter what floor you're on, they communicate to each other, and they actually communicate to my smart device. And if it detects something going on, let's say it's up in the attic and you're in the basement, it actually will tell you, alarm goes off and it'll tell you, hey, smoke is detected up in the attic. You don't have to worry about a blaring alarm just running around the house trying to figure out what's going on, or that annoying beep, and you wait for 15 minutes, find out your battery's low and you're trying to listen to which one's the battery's low. No, it tells you, the smoke detector in the basement's battery is low, go change it, and so it's just this type of thing that can be so powerful, and, you can use it to really understand what's going on so readily. And so, a lot of these concepts can be rolled over, right, into, developing a smart machine. But I have some questions that we'd like you to kind of answer here. Why would you be interested in a smart machine? And kind of, put on here what you think it would be, and maybe we can talk about that in a little bit. But then, so what is a smart machine? A smart machine, if you haven't been living in that world like I have, it may not really hit you exactly what a smart machine. But a smart machine is taking real-time data, and it's more than just a sensor that turns off and on. It's getting a sensor, and it's getting additional information about the world. It's understanding, details about that equipment. And you take that information and you get all that information together, all this data, real-time data together, and you try and contextualize it, right? And what I mean by contextualize is, you can have all this information, but it doesn't mean anything if you don't understand your equipment. And isn't that how you can really differentiate your equipment? Because when you sell it to somebody, they don't understand, they weren't the engineer designing this equipment. So they don't understand what all this means. But you, as the OEM or the developer of this equipment, you really understand, the context of what all this extra data means. And then you take all this data and you analyze this data. You figure out, this data that I've kind of, coming from my machine, what does it mean? Can I do some preventive maintenance from this? Or can maybe I make some adjustments to the equipment to make it more efficient? We're going to hopefully be getting into that a little bit. Because that's one thing that we really did on our equipment is we would get this data, we'd automatically make adjustments to make our equipment run more efficiently. Then you start doing that. You optimize your machine to make it a more efficient machine. Now, today what we're going to really talk about is that real-time data portion. And this is going to be a multi-part series on getting smart. But this is the main focus, foundations, getting the data. And then we'll kind of go into in a few more about contextualizing this data, right? I want to give you an example. I was thinking about what example in the real world can I use to give you maybe that concept of what a smart machine is. And it just so happened I bought something new. I'm a cyclist. I love to get out and bike. And during the winter, it starts getting down, it gets down below 40. I'm not liking to get out there as much as I used to go cycling in the winter. And so what happens is I kind of get lazy, and throughout the winter, I kind of get out of shape, right? And so we bought a trainer, and we stick our bike on this trainer, and you sit there and pedal. It is so boring. And so what my wife and I would do, we would go to spin classes. Well, this past year, spin classes aren't available. And so my wife and I, back in November, we decided we need to do something. And so we bought a new bike trainer. And this is a smart machine bike. And I want to draw some parallels here. And so this smart trainer, I take my bike off just like I do my regular trainer off the wheels, and I stick it on this trainer. And I connect the forks to a device, and I connect the sprocket to another device. And I put on a heart rate monitor, right? And you start pedaling, and also take a laptop, and I put it in front of us. And you run a video, and it's a video with information in the background that talks to your smart trainer. And the one I was running actually last night again, I was doing this, it was a Tour de France video. Of course, I could not keep up with these guys. But what's really interesting is I'm pedaling on my trainer, and I'm watching the video go, and someone will say, a hill's coming up. I was like, okay, a hill's coming up. I'm pedaling along, and all of a sudden, the front of my bike starts raising up, and the back wheel starts getting harder to pedal. And sometimes I actually have to, just like going up a hill, I have to, change my gears to get up this hill. And it's telling me how many watts I'm doing. It's telling me what my heart rate's going on, right? And so somebody has looked at all this information, and they're gathering this information, this data, and they're contextualizing it in a smart bike, and they're starting to do some analysis. They're saying your heart rate is this, but you need to be at a little higher heart rate. And so you get this little, verbiage out in the background says, pedal harder. They're getting away from you. It's actually to the extent where if I start pedaling, your little avatar gets off your bike, kind of say, hey, you're getting lazy here. Get back on your bike, And so, you're putting this, all this information together to optimize your training. And I'm telling you, it works. It works so much that I'm doing this every other day where I used to hate getting on my trainer. And I want to tell you, the value is really seen by the cyclist. And how I can tell you it's seen is that trainer that I bought, it sits in a corner, and you can buy them anytime you want at so many places. But you want to get these smart trainers, they're like a 2-month backlog because people realize, they understand the value. I can get either this cheap trainer that I won't use, or I can get this smart machine that just makes me want to get on and train. And we're going to talk a little bit about adding revenue stream. And this is where these people have also added a new revenue stream, right? You can buy, this, for $15 a month, you can get this personal trainer who will, work with you and make sure you're adding, you're getting the workout that you want. And so that's kind of what I would call the definition of a smart machine and what a smart machine is. And so let's get to maybe a little bit of your results here of the poll. And, what's your primary interest of building a smart machine? So adding value, isn't that a huge piece? Because we want to differentiate our equipment from our competition, right? And we're going to talk about a little bit more in the next few slides here. But adding value can be huge, right? The other one is reducing costs. And that's one where a lot of people they think about smart machine, they always think, oh, I'm adding costs. Well, that's not really true. You can reduce your own costs, and I'll give you a couple ideas of how we did that with some of our equipment. Or you can reduce your customer costs. And either one of those is a good thing for your market and for differentiating you in the marketplace, right? To create a new stream of revenue. And this is another one that I probably personally struggled with when, about 15 years ago when we started talking about how can we increase revenue. And maybe we won't be selling anymore, so we want to have new revenue streams. And so we developed a method for having new revenue streams. And I wasn't convinced, I wasn't really sold on it, but it got to the point where we had to have a separate department. And it was a fairly large percentage of our, the original equipment that we were selling is what this new revenue streams were. And it had nothing to do with selling new equipment because we found the customers saw the value in that and they wanted to, increase their production output or their efficiency or reduce their downtime. So new revenue streams are a real thing. But I'll tell you, it's not as apparent sometimes. Another one is to reduce risk. And there's different types of risks that we'll talk about, right? There's safety risk, there's risk to you as your own, there's risk to your customer. And so that can be a real thing also. And it's really, we got to look at the context here. What type of risk are we wanting to reduce? Intellectual property or safety or whatever it might be. To bridge the skills gap. And this is one that I have really been coming across more often is the skills gap. And there's a couple pieces of this, right? The skills gap, when you have new equipment coming in and people don't understand it, or you have engineers leaving, right? This is a gap that is a lot of times is very hard to overcome. Is this skills gap, and so we can talk about that in more detail. But that's one where I would say once again, if you're seeing skills gap, it's one thing we definitely had to address. But book a meeting with Jeremy and John, and let's talk about your specific situation, whether it be adding value, reducing cost, risk, revenue, skills gap. And, let's talk about what your specific situation is and how maybe we can apply this. Maybe I can use some of my experience to help you apply this. So, the ultimate question is, why build a smart machine? And I got to tell you, every time I see this comic, it just hits me. I love this comic. Everybody who's got an OEM. It started somewhere because they thought they could build a better mousetrap. And one of the guys I worked for, he started pizza shops, and then he thought he could figure out ways to put toppings on pizza. And so he developed an OEM to do this. And one of the things he figured out is people were copying his equipment, and so he always had to be better. But so many times, an OEM develops a piece of equipment and they start getting competition in the marketplace, and so it starts driving the price down, right? And then it becomes this price war that, in reality, you never win. Because when your competition drops their price, you got to drop their price, and basically what you're talking about is reduced margin. So how do you get more margin? Then you start looking at cost savings, when that's not really what got you to start a company in the first place. It's about developing new technology, putting round wheels on, the old square wheels, and making your equipment more efficient, and once again, differentiating you in the marketplace. And that's really what getting to building this smart machine is all about. Let's talk about some of these things, reducing costs. I want to start there because it's not always really apparent. One thing that we did to reduce cost is what we would call modular code. Is when we would write code and we had a piece of equipment that could go to many different customers that had different needs, right? And so our code had to have different configurations. And so when we were setting up a machine with this code, it could take 5 weeks to get this code ready to test. And so we made our code modular, and actually we made it so it would self-set up. An engineer would sit down, put information in a spreadsheet, and then it would set up the code to run in a particular manner, to get that equipment or that code ready for the customer. We went from a 5-week setup time down to about a 1-week setup time. 4 weeks of savings was huge for us, right? And so modular code was one thing. Another one is equipment efficiency. And I'll tell you, this is a savings maybe not for you, but for your customer, and that's a huge differentiation. So we would do things in our code, and we would watch, what the customer's equipment interface ours was doing, and we get feedback from that from our intelligent sensors. It would tell us if we make these adjustments on our equipment, our equipment's or our customer's equipment would actually become more efficient. And I'm telling you, that is huge to our customer when your equipment can help your customer be more efficient, either through throughput of your equipment or how your equipment operates or reduce downtime. Any of those things, is reduce cost either to you or your customer. Another one that was really unique when we started getting into it is, developing one machine that could do the tasks of multiple machines. And we ended up developing a piece of equipment, one piece of equipment that could take the place of 10 to up to 20 pieces of equipment. And, so we had higher margins on that equipment. And it was a huge differentiation for us. And it was one of the things that really helped us, to take over, be the leader in that market, right? And so reduce costs, there's many ways of looking at that and many things that you can get out of that. Another one is, let's go down to reducing risk. And this can be either through integrated safety, or this can be through intellectual property protection or other things. And there's different types of risk, right? There's your own personal risk to your company, and maybe there's safety risk to your customer, where you can integrate your safety into your controls. And we'll talk a little bit more about this later on towards the end of the presentation, where safety used to be kind of its own little thing, and it was frustrating, honestly. But you can integrate the safety into the complete control package to make it a piece of integrated equipment that is just so much more functional. Intellectual property, I want to talk about that just a moment here, because that's one of the things that we did look at was intellectual property. So we had a competitor that was always driving price down, right? They didn't have a big R&D department. We did all the development. Then they would look at what we developed. They copy what we developed, right? And so they were able to keep their engineering costs low, which allowed them to keep their costs low. And so we were really concerned about protecting our intellectual property. And so that's one of the things that we put a lot of emphasis on, was protecting that intellectual property that we had developed. And there's ways of doing that. And once again, if you have a concern about that, we've got some friends of ours that's going to be coming on later that can kind of maybe talk through that more in one of these series coming up, is how to protect your intellectual property. But there's ways of doing that. And one thing I will tell you is some people also use this as a new revenue stream. We didn't do that, and that's really because I wasn't sold on it. I never really liked the thought of charging, for some of this protection. But it is a thing, and it is growing in the market. But we didn't do that. We just really used it to protect our intellectual property. Another thing I want to talk about is adding value, because adding value really is, I think, where most people, and if we look at the polls, that's kind of what a lot of people think about, is how do I add value to my equipment to differentiate myself in the marketplace? Smart sensing is a huge piece of this, and you really need that smart sensing to try and figure out what's going on to possibly reduce downtime. And I'm telling you, reducing downtime is huge, because whenever your customer's equipment goes down, they're frustrated, and they correlate that to your equipment. Whether they're doing something wrong or not, they're thinking, this equipment went down, I'm frustrated. So reducing that downtime, or being able to sense what's going on with the equipment and predict, hey, this is something that needs to be taken care of, and so I'm going to do preventative maintenance before the equipment goes down. And we'll get a little bit more into that in the future as well. One thing that we did to reduce downtime is sensor failover. We would have sensors that on lines that were, if they went down, it was millions of dollars, right? And there's a lot of production lines out there. And I think you'd be surprised when a customer's production line goes down, what that cost is to them. And either, they have to send people home because it takes so long to fix, or, people are just sitting around, lost production, frustration, all those things. But we had sensors that would figure out when they're starting to fail, or they failed, and roll over to a backup sensor. And, so customers, and some of these sensors aren't that expensive, right? And some of the customers just love this, of being able to, their line just may have a slight hiccup and then keep on running, and you don't have a breakdown, right? Adaptive control, and that's another thing that we used. We had a servo system that would adapt the control to what was going on. So that adaptive control would sense something going on in our customer's facility, and so our equipment would adapt to that. And and that's one of the ways that we made our customers end up, final, process to be more efficient. Line efficiency, we've talked a little bit about that, and there's other, things that we want to discuss, such as the online manual, which is something that, when I started with was my simple online manual that would pull up, when a sensor tripped. We actually developed, and the engineer that worked for me during this time that developed this did a great job. It would actually look at what was going on with equipment when sensors would trip, and it would actually do logic to figure out what caused the machine to trip. And it would actually lay out the process of getting the equipment up and running, and it would, bring that up right to the operator. As soon as something happened, it would say, here's what's the cause of it, here's what was going on. So we tell you, this is what you most likely need to go check to get it running as fast as possible. So I'm telling you, that is something that's so frustrating to a maintenance guy, is to hear, okay, a line's down, I gotta go figure out why. And you know what? I really don't know. And so you got to go start digging into things. And he's under the pressure. People saying, when are you going to get our equipment up and running? Downtime. So frustrating. Let's go on to the last one, and that is new revenue. And that's the one where it's not always so obvious. But I'll tell you, there are potentials for new revenue, whether it be remote access or hardware licensing or whatever it might be. But the remote access, that is one, I tell you, I really see the value in remote access. Part of it is because what we experienced, we developed a system where it would gather all this data. And once again, your customers didn't develop this machine, right? They bought this machine. They don't thoroughly understand, why you did what you did. And so we would take all this data, and periodically that data would be pulled up to us. And we do two things with that data. We had this history that we would develop, and this data would go on actually for years after a period of time. And when we would see something would happen, say, if this happens, if we make these adjustments, the equipment we either can do maintenance or we can make it more efficient. And so this was a service, and this was a new revenue stream for us, is getting this data up and writing reports for our customers saying, if you make these adjustments either to your equipment or to our equipment, you can get these benefits from it. And so that was one of the really big new revenue streams from us. And so those are just some of the reasons why, to build a smart machine, and there's others. And I didn't talk about all of these, but if you see one, once again, that triggers something to you, let's talk about it. Because most of these, I've tried or have worked on or been involved with and have seen the benefits. And maybe we can look at your equipment to figure out, what we can do with your particular situation. So let's go back to that piece of what we want to talk about today. That is, data is the foundation. If you listen to all the things I've been talking about, it's getting data from your equipment. If you can't get that data, you don't know what's going on, right? And so that data is the foundation of doing any of these aspects. And what I would say is, gone are the days where a sensor is a 1 or a 0. So some of you, may not really understand why I mean that, but it's either off or on. So what sensors always did in the past is, something would go by a sensor and it would trigger it that would make something to happen. One of the first projects I worked on was, early on in my career was we had mechanical cams, and this rotary machine would come past, trip a mechanical cam, and have something happen. Well, the reason we wanted to change it was every time we wanted to do a new setup, you had to stop the machine, you had to adjust this mechanical cam. And there was a lot of tweaking of this. And so every time you wanted to make a new run of a product, you had to adjust these cams. And so we developed what we call an e-cam, or electronic cam. And it was basically just a sensor going past a dog, that would trip it. And then you could adjust timing in a PLC. And that was kind of the first step in my career of saying, oh, wow, automation can really, change your life as far as setup goes. Because at that time, we're running short runs of things. And so you had to do a lot of setups. Well, you can take that and you can put that in a library and you can have your equipment automatically adjust to things. But we had to be able to sense that, right? And with a sensor, you can do things like you can look at margin alarms. You can figure out, hey, this sensor is not sensing like it used to. This is one of the things where you can, send a message or a text, to the maintenance guy on his phone and say, hey, you need to go look at this sensor. it's getting ready to alarm. You can look at multiple configurations, and it's getting all this real world data. It can be something as simple as LED lights. This sensor has failed, and so this LED light turns on. But I'll tell you, you can go so much further than that these days. But really, getting that data is the foundation to being able to develop a smart machine. Another piece of data as a smart machine is not just what I would call the on and off sensors. It's also your electronic overloads or your motor starters or your contactors. You can get so much more information other than just turning on the motor and it runs. Bimetal overload, things shift around, and so it trips, and so your motor stops. There's so much information that can be gotten from these electronic overloads these days that can tell you so much of what's going on with your equipment. It can be integrating the safety. That's another thing of this total machine package. But once again, it's getting these sensors that can detect a lot of information. And one thing I want to tell you is, these sensors, if you're buying them from Rockwell, most of it's there. You just need to tap into it and access it. And so what we do is we get all these sensors and we put them on a network, right? And, eventually what's going to get it? It's going to get up to an Ethernet network, and it's going to put all this data together. And whether it's an encoder, whether it can be a pressure sensor, a temperature sensor, a photoelectric, it doesn't matter what it is, it's going to come up to this network, and then you're going to start analyzing it. But you got to get this sensor on this network to get it up to your basically your brains of what's going on. But what I'd like to do at this time is I'd like to introduce you to John. John's an engineer that works at CBT, and he's going to tell you a little bit about some of these sensors that you can get through them from Rockwell that will kind of help you, get this data. And so, John?
Hello, my name is John Simon. I work here at CBT as an automation specialist. Today I want to give you a brief overview of the Allen Bradley smart sensors. There are two different types of smart sensors, Ethernet IP and IO-Link based sensors. First, let's talk the Ethernet IP sensors. Allen Bradley offers a 48CR barcode reader, an 842E encoders, and 56 RF RFID readers.
In this application scenario, a range of smart sensors are used for production tracking and historical trace requirements. For item level tracking, a high-speed code reader captures barcode or 2D code data and communicates this over the Ethernet IP network.
The Ethernet IP sensors have an add-on profiles that help with the ease of integration into your Logix application and create specific controller-based tags for the sensor. These sensors also help reduce installation downtime and save on cost of wiring. Next, IO-Link. IO-Link is a worldwide open standard protocol that allows sensors to easily integrate into the connected enterprise. Allen Bradley offers two IO-Link masters, the 1732E on-machine master and the 1734 point IO master. Once adding the master into your IO tree in your Logix application, you can get an add-on profile that allows you to enter the IO-Link sensors into the application. Allen Bradley does offer photoelectric, ultrasonic, proximity, process, and even electronic circuit protection on IO-Link. Each of these sensors can be purchased with the IO-Link technology already embedded in them at no extra charge.
In this application scenario, a forklift driver reverses into the packaging line, damaging a smart sensor. A maintenance person receives a warning on his mobile device that there is an issue with a sensor on line number 2, conveyor 1. The exact location and additional sensor information, such as the sensor's part number and supplier, is available via the mobile device. Having this information, he knows which sensor to select and install from stores. After physical installation of the new smart sensor, the automatic device configuration function downloads all sensor parameters to the new sensor in milliseconds.
IO-Link gives you some maintenance benefits that include low margin alarms, automatic device configuration that allows for sensor parameters to be pushed out to the sensor instead of having them to teach on the line. You can create descriptive tags for each sensor, even turn on a sensor locator to help locate the exact sensor you are looking for, plus much more. In the resources section of this, we have created a smart sensor portfolio that goes into more detail of all the smart sensors that Allen Bradley has. If you would like to discuss this further, please go and book a meeting, and Jeremy, Watkins, or myself will be glad to help you.
Well, thank you very much, John. And that actually had some good visuals of some things that you can do. But let's go on beyond sensors here a minute. Let's talk a little bit about the electronic overloads. What's some of the things that you can get from an electronic overload other than your equipment shut down here? So what we used to do is take a CT, put it on the motor wiring, and then our next thing is we would put multiple CTs on so we could look at each phase of the wiring and we can detect different things. Well, now you just take your electronic overload, and of course you can figure out the current, you can figure out the thermal capacity utilization, trip warnings, time to trip, time to reset, operational hours, number of starts, voltage, energy power, and power. All these things are really relevant information that you can use other than my motor trip, right? And let's get into, I want to show you a scenario of that. But I really like this next picture. Every time I see this, it just means so much more to me. And of course, it's a very recognizable individual picture, but it used to be in the past, you would have a maintenance guy that's walking up and down and he's watching the line. He's trying to see what's going on here. He's trying to, whenever something broke, he had to get to it and fix it right away. Well, guess what? Now we have a piece of equipment that's watching the line 24/7. And because it's developed by you, the original equipment manufacturer, it knows so much more than by a maintenance guy that maybe was just hired or, doesn't have the full knowledge of your equipment, but you can really know what's going on. And so you can have, your controls 24/7 watching the line and understanding, do I have to reduce the speed because things are happening, or do I need to, make some tweaks here or there? That's what this whole smart machine thing is about. Let's take an example here. And this is just a picture, of a motor and a pump. And I want to actually look at not just a pump, but I also want to look at a fan motor, because that's something that both of these are something that I had to deal with in my past. But you take an electronic overload and you can look at the voltage, you can look at the current, you can look at ground faults, you can look at temperature and energy consumption. So all these things do mean something to you. But you know what the next level on top of this is mechanical attributes. So one of the scenarios was I worked at a facility and we put in some equipment, and it was for cooling glass to temper the glass. So you had to cool it very quick. So we had this 600 horsepower motor running this fan that was, I can't remember, it was like 8 or 10 feet tall, right? And so if this thing broke down, things were down, and they weren't down for a few hours. It's more like they were probably down for a few days, and sometimes maybe a week if you weren't prepared. And so what we did is we would put accelerometers on 2 axes of the bearings, and we could tell what was going on with those bearings, the inboard bearing, the outboard bearing. And then we would walk around with a meter, and we'd take readings on the actual blower housing, and we'd take readings on the motor housing. And then we had temperature sensors, on the motor. Okay, and we would look at this information 24/7, and with the history that we would build up, we could predict out, a few weeks in advance, when something was probably going to fail on this motor. And I can remember that one time when we see a bearing, and with these vibrations, you can actually detect, is it the inner race, is it the outer race, which bearing is it? And we detected that, hey, a bearing was going to fail. And I just remember this because we were working over the weekend and late night. We caught it, before it failed, and we said, okay, on Friday night, we're going to shut down, and we're going to get the line back up and running. And I remember the bearing had gotten, really hot. It actually had fused the shaft, so we had to cut it off. We got this all, done on a planned downtime. Can you imagine if this had happened while the line was just running, and we didn't have all the product, all the bearings lined up and everything, it would have been days that the line would be down. And basically what happens is the line shuts down, no product ships. And that's where I'm saying, this can be such a huge differentiator to you. But you take these, mechanical attributes and you can start getting things like, is cavitation going on in the pump? This is one of the things that we had to deal with also is, we would start having cavitating in our pumps. It would start actually eating at the metal, on the blades of the pump. And so we would know, okay, the pump's going to fail if we have cavitation, so we can back off the speed and we can, get rid of that cavitation. You can see things, like cracked rotors or turbulent flow. That was another thing that we looked for, and is to find what we called, departure from nucleate boiling. But it was something where if you could detect, bubbles were forming in the fluid that we were pumping, that your efficiency were really dropping, and things were going on that you didn't want, so you could react to them. So condition monitoring, beyond, let's take the sensor monitoring, go a step beyond that, and let's start monitoring the conditions of your equipment. So it's beyond just sensors, it's vibrations, it's temperatures, it's pressures. And once again, as the original equipment designer, you can take that information and you can basically make your customers more successful. I'm telling you, that really differentiates your equipment or adds value. And so just like the sensors, we're going to put all this, this equipment or these products on a line, and it doesn't matter whether it's, motor starters or servo motors, or it's sensors. All this stuff is going to go on your network and it's going to come up to, the central brains. But if you notice the thing that is going on here, it's all one system. And that one system is all coordinated together. It's not disjointed. It's all, a kind of, I guess, it's all a smart, smart machine. I can't think of better words to describe it than that. But I want to add kind of the final piece to that, and that is safety. I remember, safety in the past was that necessary evil. It was that frustration. In the past, especially when I was in the food industry, I can remember that one situation where we had just built some machine. It was a new machine. We were out on the production line. And if any of you have worked on some of these food processing lines, it's not comfortable. First of all, you're in a cold environment. And then they want to shut down periodically. They want to spray caustic, either acidic or basic on the equipment. They want to come in with high temperature, high pressure sprays and spray it all down. And so we move our equipment in here, piece of R&D equipment, and, we put it on the line. And they say, okay, we're going to start back up, and it doesn't start. And I can just remember, being in my jacket, my hands cold, trying to find out why it didn't start. And saying, okay, the safety, so something has triggered the safety. And because you got flying knives in this machine, you have to actually latch these doors shut. And then, so once you latch them, it doesn't necessarily mean the sensor senses that the door was shut. So we had to have somebody sitting there as we went around, banging on the guards, trying to find out which guard wasn't latched properly. Found out which one it was, unlatch it, adjust the sensor till you get it right, and then, lock it back up and start running. That was just so frustrating. Nowadays, it's all, connected together. I remember another one was simple as an e-stop. We had a very long production line on one of the lines we did, and, it was long. As a matter of fact, sometimes they have bicycles to get up and down the line when we're starting it up. And you can be at the very end of the line and starting a piece of equipment, and the line shuts down. And so you start getting on your walkie-talkie, trying to find out what's going on. And what we found out a couple of times is someone hit an e-stop. And one of them was, an operator wanted to go on break. And so one of the things you can do is it's simple as looking at how many times the e-stop is pushed on a particular shift. And you can figure out, hey, this operator doesn't understand. There's a controlled shutdown and there's an e-stop. You do training, and guess what? your customer's production line gets more efficient. And so this is where, you can do some things, and there's things called like safe speed, safe direction, that we can talk about if safety is really something that is an issue with you. But safety has come such a long ways. And, I remember when safety was its own network, right? And basically what you got an input that your safety system was tripped. Now it's integrated into the controls, and it's sending up so much data about what is going on, with the light curtains that are on SIP safety now and all these other things. What I'd like to do next is I'd like to introduce another person, Jeremy. And Jeremy's going to talk to us a little bit about the safety sensors and stuff and give you some ideas on what the safety sensors are like and what they can do. So, Jeremy?
Hi, my name is Jeremy Watkins, and I'm a TUV functional safety technician, and I'm one of many specialists here at CBT. I've been covering our IC sensors and safety lines since 2013, and today I want to talk to you about making your safety system smarter. Rockwell provides multiple ways to make your safety system smarter. Two of the methods I want to talk about today are SIP safety over Ethernet and GuardLink. SIP safety has been out for several years now. What's new about SIP safety is a whole new generation of devices that have SIP safety built into them. These SIP safety devices communicate directly with the safety controller over unmodified Ethernet, eliminating the need for discrete wiring. Devices with embedded SIP safety provide all the advantages of a hardwired solution, but offer reduced wiring, faster deployment, saving you time and money. A GuardLink solution is more like a traditional relay, and it works without the use of a safety controller, but offers advanced diagnostic capability. Both options can provide up to SIL 3 Category 4 Performance Level E safety and provide industry-leading diagnostic information that's integrated directly into your control system. Here are some of the most recent offerings with SIP safety embedded. So released a few years ago, the 442G MAB is available as a hardwired or SIP safety version. The SIP version integrates directly into your Logix platform with an add-on profile. The MAB offers an all-in-one guard locking solution for your full-body access applications. Dual power and dual Ethernet ports make it easy to connect in series with other SIP safety devices and offers maximum flexibility. Features like unique coded RFID, built-in e-stop and enabling port, multiple lockout points, and an optional escape-release handle provide the highest level of safety for your guard locking solution. Released just this year, the 450 SIP safety module now allows you to integrate the 450L basic or enhanced light curtains directly into your Guard Logix platform. All the 450L's functionality, like muting, blanking, and cascading, can now be integrated directly into your Studio 5000 project. For smaller and simpler applications where a safety controller is not yet needed, the GuardLink safety system offers a robust and cost-effective solution. GuardLink allows you to connect up to 32 safety devices in series over simple M12 connectivity. You can easily connect safety devices such as e-stops, guard locking switches, interlock switches, and light curtains. GuardLink brings back data-rich diagnostic information to your control system without the need for discrete wiring, eliminating cost and complexity from your safety system. The 440G MZ is Rockwell's newest solid-state guard locking switch. It's one of the first safety devices to be offered with GuardLink capability embedded. Simply put, it can be easily integrated into the GuardLink safety system. Available in power to lock and power to release, the MZ's robust frame offers 2,500 newtons of holding force for partial or full body access. With an RFID built directly into the actuator, OSSD outputs, the MZ meets SIL 3 Category 4 Performance Level E, offering you the highest level of safety. The 440G EZ is Rockwell's new power-to-lock electromagnetic guard locking switch. The EZ is designed to provide the protection of an interlock safety switch while protecting your process from unplanned downtime. This improves productivity and increases your efficiency while providing the highest level of personnel safety. The MZ and the EZ both have options for 5-pin and 8-pin M12 connectivity and can easily be integrated into a Guard Logix controller or a GuardLink safety system. No matter the size of your safety system, Rockwell has a smart safety solution to fit your needs. Book a session with John Simon or myself to talk more about how we can help you make your safety system smarter.
Well, thank you, Jeremy. So if you look at what some of the things Jeremy was talking about, I think what you can see is, there's a lot of advances that have gone on in safety. And if safety is something that, once again, you're interested in, let's talk about it. Whether it be, the safety scanners or the light curtains or, simple e-stops, whatever be one of those. Let's talk about, maybe how you can integrate those more thoroughly into your system. So I know we've talked a lot and we've gone through a lot of information, and to be honest, sometimes it's kind of hard to talk about 30 years of development experience in automating equipment, but it's one of the things that I really enjoyed in my career. And honestly, with this pandemic and being kind of locked up in my house, I really haven't gotten much of that lately. And so what I would say to you is, first of all, is, take advantage of booking that meeting with either Jeremy or John. And if you're interested in maybe some ideas, I'd love to either meet with you in person or by, a remote call and talk about some of your applications and maybe taking that first step. Because one thing I do understand is, often it seems daunting or overwhelming if you have a basic system and say, okay, I want to differentiate my equipment, but my goodness, look at all I have to get to do it. It's really not that. Sometimes it's taking that first step and kind of, marching into it a little bit, or taking the first step and saying, okay, what's the biggest problem my customer is having? One thing that comes to mind is we were talking to a customer about 8 months ago, and their frustration was they shipped their machine from Ohio to California. And when they get out there, run for a while, and it'd break. And they said, so they'd send someone out there to fix equipment, and they said sometimes they're actually on the plane when it breaks again. And they said all they do is they go out and they fix a problem, but they don't know what's causing the problem. And so sometimes it's just putting sensors on there so you can detect, here's what's going on. And so it can maybe just be simple training. Okay, you're not really operating our equipment properly. It was designed in a different manner. Maybe it has a high inertia startup, and so you're starting, stopping, which is reducing the life. There can be a lot of things, but it can just be gathering that data. So you take that first step. And then after you get that first step, then you kind of start taking the next step once your customers start being value, and it kind of builds on itself. But today, what we were really talking about was, the sensors and the basic platform. In the next, series coming up of this Get Smart, we're going to be talking a little about, with Jeff Waters, about some of the advanced features that are available to you that you can kind of work with, and how we can kind of take some of those next steps. So I'd invite you to join us on this next webinar. And I'd like to turn it back over to Callie as she wraps things up for us.
On behalf of everyone at CBT, I'd like to thank you for attending. We'd really appreciate it if you filled out the survey so that we can continue to tailor our content to match your needs. I know we covered a lot of information today, but the most important takeaway is that you don't have to go on this journey alone. CBT has the resources to help you begin implementing smart technology in a way that works for you. We encourage you to use the Book a Meeting icon and get time scheduled with a CBT professional to speak about your individual needs. And we'd also love for you to use the registration icon and join us in the next installment of the Get Smart series. Thanks so much for your time, and remember to work smarter and not harder.